Hello, and welcome to Module 2, Part 1, where we're going to look at scatterplots and correlation. Part of what we're looking at today is when we've gone out and we've collected not just one set of data that we're analyzing, but rather two sets of data that we may suspect have a relationship with each other. And when we talk about relationship with each other, we're talking about whether one may have an effect on the other. So, in a sense, what we're looking for is cause and effect relationships. Usually, we've tagged one variable as causing or influencing the behavior on a second variable. There can be positive relationships between these two variables, which would mean as one set of values are increasing, we see a second set of values also increasing. So if they're both going in the same direction, if x is going up and y is going up at the same time, then we say that's a positive relationship. As one variable increases, the second variable also increases. We say it's a negative relationship if they're going in opposite directions. So as one variable is increasing, we see a decrease in the other variable and vice versa. In the big picture, there can be linear relationships, meaning that as one set of data is increasing, we're seeing a steady and consistent increase also in the other data. It could be that we see nonlinear relationships, meaning there's a relationship, but the line does not necessarily isn't the best description of their relationships. It's possible that for a while it may appear linear, but then we may start to see a decrease and also hence a same decrease in the other. So you can have parabolic relationships. If you think back to the parabola, there can be exponential relationships between variables. So there's all kinds of relationships. We're mostly going to focus in this section on linear relationships. And it could be that we discover there's absolutely no relationship between our variables and our data. One way to display and to analyze whether or not there appears to be a relationship is to really look at a picture of our x and y values, our one set of data paired up with the other set of data's ordered pairs. And if we just display these ordered pairs in a graph, we call that a scatter plot. It's simply looking at all of these ordered pairs in a rectangular coordinate plane. We don't really connect the points because there is no necessary order to them at all, but rather just look at them as a whole, as a picture, a big picture. I say here that it usually uses only the first quadrant. That's not always the case, but typically we tend to see them fall into the first quadrant simply because when you're dealing with real-world values, a lot of times negative numbers don't really come into play or they don't really make sense. For example, if on our horizontal axis, if you can picture an x-axis, we've got time as our variable, a negative time doesn't always make sense, right? And if we're talking about distance on the y-axis, negative distances don't always make sense. So in a lot of real-world data, when we talk about the negative numbers that sometimes appear in just random selections of data, or random numbers or formulas can a lot of times use negative numbers. We can just plug them in. But a lot of times they don't make sense in the real world situation. So let's talk about independent and dependent. The y-axis we use for our independent and the x-axis is used typically for our independent variable. And the y-axis is used for the dependent variable. You may have heard these terms before. In terms of statistics, when we talk about the independent and the dependent variable, the independent, we call it that because it's the one that's having effect on the other. And so the y we call the response or the dependent because it's depending on the and what occurs for x. So some other words we use that are a little more specific to the situation we're talking about here is that the independent variable is our predictor or our causal variable. It's the one that we can use to predict the outcome in y. And it's the outcome, it's the variable where we actually say it's causing the response in y. And so, as you know, the x-axis is typically used is the horizontal axis, and the y-axis is the response. A lot of times, though this is a little bit arbitrary for us to say, because in a technical sense, you can always just switch the variables around and put one on the other axis. But visually, when we see an x and y axis and we put the x as our independent and our y as our dependent, when you're seeing an increase, you're seeing a line going upwards. And so visually it works for us to choose y for our dependent variable, our response variable. So for example, here there may be a causal relationship between hours spent studying and your grade in the final exam. Which one of those would you feel is the independent variable or the causal variable that causes a response in the y measurement? In this case, we would say most likely that the hours spent studying would be a predictor of a grade on the final exam. And in this case, we would say that the independent variable should be the hours spent studying because it should be a predictor, though not a perfect one, of the grade on the final test. And this should be a positive relationship between the two, as the numbers of hours spent studying, again, typically, we should see a response, or we would expect to see a response from the y, which is your grade on the test. So here we go with an example. The following table shows data of the ages of children and their corresponding heights. So here we have a set of x's, which we would say is our independent variable, ages of children, and then the corresponding heights in inches. We say that would be the response. We would say age would be a good predictor of height. Now, we're going to look at how to put this into your calculator. Because on your calculator, we can actually view a scatter plot. Now, I've got my handy-dandy calculator here, so I'm going to take us out of the presentation mode here and see if I can grab my calculator so you guys can follow along with me. And here we go. So the first thing we want to do is to create our list of x and y values. So you guys have done this. We're going to go to Stat. And Stat takes you to the screen. We're going to be using Stat a lot. Of course, it stands for statistics. And when you go to Edit, what Stat is typically used for is to input a bunch of data and then to get numbers and to do stuff with that data. Right? So the first thing we always have here is Edit. We're going to go into that screen and we're going to input these numbers that are on the screen into List 1 and List 2. Now, a couple things I want to show you on your calculator. Now, List 1 and List 2 typically tend to be the default lists. In other words, you don't want to lose them. And one of the things that happens is people will accidentally delete their list. So I'm going to go through this and just show you a couple things. I'm going to create a list here in List 3. And this is going to be just my trial list because I put these in beforehand and I don't want to get rid of them. Just to speed up the video here. So List 3. If you ever want to clear a list, the way you want to do it is to go up and highlight L3 and hit Clear and then Enter. That will clear out all the numbers in your lists. You could also go down and delete them individually, right? If you ever want to delete an item in a list, just highlight the one you want to delete and hit Delete. What you don't want to do is to delete your list. So what you want to avoid is highlighting L3 and then hitting Delete, because that actually gets rid of List 3, which is a really weird thing that happens in this calculator. All right, so oh my gosh, there's no more list 3. Where did it go? And you could be even more afraid if it's list 1 and list 2 because that happens to be your default list for a lot of different things on a calculator. Don't worry, you can get it back. It's actually fairly easy. Notice that above delete, there's the word insert. So if I go second insert, as I'm highlighting L4, it's going to scooch a new list in there. Notice it scooched L4 to the right. And it's wanting me to name this list. Notice that L3 is the one I got rid of, so I want to name it L3, which is above the 3 button, and it's blue, meaning I need to hit second before I hit 3. So I'm going to go second, L3, hit enter, and it puts the list back. And not only does it give me the list back, it gives me those numbers that were in list 3 before I deleted it. All right, so that's how you can get your list back if you ever accidentally delete them. I know delete just, just kind of like pulls you to it. It's like I want to get rid of this list, so I want to delete it, right? But no, you want to hit clear and then enter. That'll clear out that list, okay? So if, for example, I delete list 1, and I'm not going to do that, you can get it back. Okay, if I deleted list 1, I would actually highlight list 2 because there would be no list 1, it'd be just list 2. It's going to push list 2 to the right, and it's going to give me, when I insert, it's going to push list 2 to the right and insert list 1 back into the program. Okay, so pause the video now, and I want you to put into list 1 all of these values, and then into list 2 all of these values. Okay, so assuming now at this point you have entered those values into your calculator, one thing you want to make sure, and this happens quite often, in fact it happened to me as I was putting this list in, I actually then entered 2 of the same values into list 1, so I repeated 2.5 I think in my list twice, and so when I finished with list 2, the 2 lists were not identical, so meaning that one had more. So like for example, if there was a 6 here, you can see that the value of 6 has no output or no y value paired with it. That's going to be a problem in your calculator. You're going to get an error. So always make sure that your 2 lists are lining up with each other, that every x has a y. And if not, just go back through the list and delete and or insert in the spot where you want it to, and it'll shift the list down. Let me just give you an example here. Let's say that I neglected to enter 44.5 when I was doing the list. It happens. All right, so I'm gonna hit delete and just delete that value. So I get to the bottom here and I realize, whoa, I need to delete the 6, but there's 2 values that don't have a y. So then I go back and I figure out, first of all, let's just get rid of the 6 here. I figure out that, the 4.8 is supposed to be paired, as we look over here, with 44.5, not 45.8. So 44.5 is the number I neglected to do it. So I don't have to start the whole list over. I just hit second insert. You notice that push that 45.8 down, and now I can put in the value that I really want here paired up with 4.8, which is 44.5. Okay, good. So that's just a few little tricks that get people caught up. Now, we've got our successful lists. Make sure it's always good to look over and make sure that your numbers are pairing up. I've already done that here. So just taking that little bit of time can save you from having to regenerate an entirely new problem because you missed something because one of your numbers was wrong. All right, let's create our scatter plot. Now, most of the time, your ScatterPlot function is not going to be turned on in your calculator, so you have to turn it on. It is located in 2 spots. You can see if it's turned on in 2 spots. You can go to StatPlot, which is above the y equal to, but you can also go to y equal to. I'll go to the screen really quick. If either plot 1, plot 2, or plot 3 is highlighted, which they are not, you can go up to them and hit enter, and that will turn your plot function on. So you can always tell if this plot 1 window is highlighted that your plot function is indeed turned on. If it's, and in this case I'm going to turn it off because I want to turn it on the other way, I'm going to go into second y equal 2, which takes me into the ScatterPlot function. And you can see that plot 1, plot 2, plot 3 are all turned off. I actually do have a plot 5 here that's turned on, and I'm gonna turn it off because I don't want it to be on, so that's going to mess me up. We only want to have one plot thing turned on, so I'm going to hit enter here. We're just going to go ahead and, whoops. Okay, let's go back up to StatPlot. I'm assuming this is a little bit weird, and I'm just looking at this particular program for the first time. I don't think that's going to give us any problems. But I'm going to highlight plot 1, which you can see is off. The reason why you have so many different plots is a lot of times we like to plot pairs of data simultaneously with each other, so they give us 3 or 4 different plots. And here you can see what the default list that it's going to pull from are. But if we hit enter on one there, it takes us into this function where we can turn the plot on just by hitting enter. And you can see the black is highlighting the on. That means stat plots are on. And the first thing here, which should be automatically on, you can see there's several different things you can graph on your calculator. You can graph a scatter plot, which is your first one. You can have those points connected, which is the second one. You can make a histogram, and you can make box plots, which we haven't really talked about yet, but we will eventually. So you want this first one highlighted, and here you can change what your X is being pulled from and what your Y is being pulled from. So like I said, automatically it's from list 1 and list 2. You can change that simply by going, for example, second L3. That would change this to pull from L3. And then the color is going to be blue. Most calculators I've seen, this one's like the TI-83 Plus C Silver Edition, so it has a few more. It's like the latest one. A few more things. Most of these are not in color. All right, so I'm going to hit enter. Enter, enter. Everything looks good. All right, so I'm going to go to graph my function. And so I'm going to hit graph. And there's no scatter plot. What happened? I want a new calculator. It appears to be broken. It really is not broken. Actually, the problem is that my points are way up here, because if you look at your X values, they're going from 1 to 5. Well, these are set at a default of going 1, 2, 3, from going basically -10 to +10, -10 to +10 on your calculator. That's your default. And look at how high the Y values are. They're way outside that 10 range. So the problem is that my window is not set correctly. And if you go into window, you can see what the settings are. Again, this is your default of what your windows are. So the problem is not that my calculator is broken, but rather that my points are outside of the range of my window. Now, luckily, in Zoom, we have a function that can just set a window that is pre-fit for these particular points. Choice number 9, zoom stat, which for most of you have to hit the down button until you get to it, or you can just hit choice number 9. I'm going to hit that. And that creates a window from whence I can see my points. All right, and there's my scatter plot. There's my scatter plot. It's simply a bunch of points. And what we see with this is that the points do appear to have somewhat of a linear relationship. It's not a perfect linear relationship, but it is a linear relationship between the points. And so that gives us some pause here, and it actually falls into our expectations that as kids get older, they tend to get bigger. As all you parents out there know that to be the case. Okay, so that is our scatter plot. I'm going to go back into our presentation here and skip through all this. We've already done that. All right, so the previous example shows a positive linear relationship between the x and the y variable. This occurs, and if you remember back to lines, this happens when the line that we see with those points is going up from left to right. So as you remember, hopefully, that it means we have a positive slope there. So when we have a positive slope with that sort of invisible line connecting all those points, that means that we have a positive relationship. If the line is going down from left to right, that would also indicate a negative slope and henceforth a negative relationship between x and y, as x is increasing, y is decreasing. And so here we see those different relationships. A lot of times we will have really strong relationships. We can have perfect linear relationships, but that's rarely the case. But we can have very strong linear relationships, and we can have very weak linear relationships, where if we look at these points, yeah, they kind of do seem to be increasing, but in a very weak way in both cases. And then there are cases where there just doesn't appear to be any relationship between them. All right, so decide whether the following, to your best guess, would have a positive or negative relationship or no linear relationship at all. Think about again, positive means as x is increasing, y is increasing, and negative meaning as x is increasing, y is decreasing. The number of absences and the final grade in a math class. First of all, we want to think about what would be my predictor and what would be my response variable. The predictor variable in this case would probably be the number of absences, and then the response variable, the y, would be your final grade. So if the number of absences is increasing, that being our x, what would we expect to happen to y? Well, we'd probably expect to see that go down. So that would be a negative relationship between x and y. As one is increasing, the other is decreasing. All right, the price of a car and the mileage of the car. Here our predictor variable most likely is mileage, and then the response would be price, right? And again, as the number of miles is increasing, our predictor, we would expect to see a decrease in the price of the car, so a negative relationship. Age in the amount spent on medication. Usually I get a few snickers on this one. So here we would probably say age would be our predictor variable, and then amount spent on medication would be the response, and that would be correct. And as one is increasing, we generally would expect to see the other increasing as well, so that would reflect a positive relationship. Then we have eye color and shoe size. Well, there's probably little to no relationship between these two variables, so yeah, no relationship at all. All right, so we have that visual, the scatter plot, to give us kind of a visual confirmation or suggestion that there appears to be a relationship or there appears to not be a relationship. How can we actually get a number or some sort of concrete measurement to say how strong that is? Because we see there is a bit of a spectrum there between strength and no strength between the relationships. And the answer is this thing we call the correlation coefficient R. Basically, the way R works is the closer R is to 1 or the closer R is to -1, the stronger the relationship. So R is a value that goes between -1 and +1. And the closer R is to either end, either a -1 or a +1, the stronger the relationship. And the closer R is to 0, 0 is the point where we have absolutely no relationship, no linear relationship whatsoever. To find that value R, we use this formula, which is a super complicated formula. You can see, and most people kind of gasp when I pull this up, as you may have as well out there in internet land. But yes, it is a bit of a complicated formula. But we're going to use the calculators on this one to help us find. So here's how we do it. And again, I'm going to exit my presentation here for a second and pull out my calculator. And we're going to go back to stat. Now, the first thing that most of you are going to have to do, and I'm not even sure, I just got this calculator. I'm I'm not even sure exactly how yours is set up, but I'm going to go ahead and go to where I know I need to go, which we went to Stat, and then notice that I hit the right arrow and I highlighted Calc across the top. Choice number 4 is the one we want. So I'm going to hit 4, and then I'm going to hit Enter. We see that it's going to pull X from list 1, Y from list 2. Don't worry about the rest of it. Most of you will just have to hit Enter. We're going to hit Calculate. And here we go. So what I see here is that my calculator is not set up quite yet. My regression function has not been turned on. So we need to turn that on, and this is true for most of you who are dealing with newer calculators. And so what we have to do is to go into this weird thing called catalog, which is above 0. Do you see that down there? All right, and it's blue, so that means I got to hit second catalog. And now you're only going to have to do this once unless you reset your calculator. But this pulls up a long list of stuff. See if we go to D here. There's D above this button right here. You don't even have to hit alpha. Normally you would, but just hit that button. It's going to take you to the D's because we want to go to this thing called diagnostics. And you can get it just by hitting down, but it just gets really slow and annoying to get down to it. All right. So notice how it says diagnostic off and diagnostic on. Your diagnostics right now are turned off. So we're going to turn them on. And like I said, once you do this, you shouldn't have to do it again. All right, so the diagnostic on. I hit enter one more time until it says done. You want to say done, so you got to hit enter twice. All right, my diagnostics are on. So now if I go back to stat again and go to calc and choice number 4, linreg ax plus b, and oops, I did not hit 4, so let's clear that out. So you guys get to watch me make mistakes here too. We're going to go to stat and then choice, and then we're going to go to calc. And I think I hit enter instead of hitting 4. So I want to hit 4. There we go. That's the screen we wanted. Go down to calculate. Most of you just have to, you don't have that screen. I don't know what this plus here is. Let's hit enter one more time. Okay, whoops. Let's try this again. You guys get to learn all types of things from now. Choice number 4. We're going to go down to calculate. There we go. Hit calculate. There we go. That's the screen we wanted. And notice that this little R here is the thing we're after. It tells me that my R value for this list is 0.9798, and that's big. All right. That's a big number, and we're happy with that. That means we have a really strong positive relationship between X and Y. I can tell by the sign of R what type of relationship I have, which we could also see that from the ScatterPlot, that it was a positive relationship. All right. So just to review, whoops, let me go back a little bit. We create our list of values, which we already had those, so stat and then edit. We choose stat again, or right to calc, choose option number 4, linreg, press enter twice. For some of you, you got to toggle down to highlight calculate and then hit enter. And there is your correlation coefficient. Generally, you're going to round that R to 3 decimal places, but that's not always the case. That's just your general rule. All right, so we have a couple of tables here. Whoops. And I want you to go now and put these into whatever you think is the more predictor and whatever would be the response. Typically, these are set up to pull the top one from list 1, the second one from list 2. Go ahead and put these into your calculator. So you want to clear out those lists that you have there. Remember to do that. You want to highlight list 1, hit clear and then enter. Highlight list 2, hit clear and then enter. And then you can put these new numbers into those lists. Do those really quickly. Pause this while you do it. And calculate the R value. Okay, now that you've calculated the R value, you should have gotten negative 0.113. So very good. Let's do it for a second table. We can see from table A that there was virtually zero relationship between age and class size, according to our data. At least it is a small amount of data, so we may want to have more, but uh, it doesn't seem like really, logically, there would have been a relationship between age and class size at any rate. All right, here we have age and the number of diaper changes. Some really fun little things here. Go ahead and put these into your calculator. Again, list 1 is actually there for you. You just got to go in and change list 2 and find the correlation coefficient for this list. The correlation for this list is negative 0.993, which shows there is a very strong relationship, according to our data, between age and diaper changes, and it is a negative relationship because the R is negative. And that concludes this slideshow.